Russia says its deep industrial backline is safe. So how did 12 UJ-26 strike drones turn a top-tier refinery into a 10-month problem in 88 seconds? And why does that threaten TS-1 jet fuel for strategic bombers? In this video, we unpack the attack sequence, the failed intercepts, and the control room lobotomy that stopped 170,000 barrels a day. Then we answer the question no headline covered. What's the true cost beyond the flames? Across supply chains, export policy, and the 1 to 15 damage yield Ukraine says it's achieving. Before we move on, please take a moment to subscribe to the channel and like the video. Russia says deep refineries are untouchable. So why did layered defenses miss 12 slow-moving strike drones? Start with the comfort story. Distance equals safety. This site sits hundreds of kilometers from the front, wrapped in Panzer S-1 and Torm 2 coverage, with electronic warfare set to smother anything that leans on GPS. Operators believed they could jam, spoof, and hand off tracks across sectors without gaps. On paper, it looks sealed. In practice, that shell had seams. The approach exploited those seams. UJ-26 strike drones came in at around 250 kilometers per hour, using low-altitude lanes that ride the terrain and trim radar horizons. They didn't arrive as a neat arrow. They flowed as staggered waves. Each wave forced different fire control units to split attention, rotate emitters, and resolve which targets sat inside missile envelopes. The spacing mattered. One drone crossing a sector boundary while another flashed through a beam forced the network to choose. Track continuity or fresh detection. Either choice left temp blind spots. Then the electronic duel kicked in. Russian denial and spoofing shoved the drones off GPS and onto inertial navigation. Inertial is steady but drifts, and drift compounds with range. At about half a degree over the route, a long leg turns a clean line into a creeping offset. Miss by that angle at distance, and your aim point slides off a critical node and onto a scrapyard. That was the bet behind the jamming wall. Enforced drift. Brake precision. Ukraine answered without talking on the air. The refinery's own thermographic plume gave a passive fix. Hot stacks and process units throw a signature you don't need to ping to see. Once the swarm had that reference, a tight, timed laser burst synced clocks and courses mid-run. No chatter, no long radio tails, just a short push to pull dispersion back to zero and restore a common timeline for the final push. Everything narrowed to an 88-second terminal phase. Interceptors split tracks as the first wave crossed the fence line. Ground guns rotated to chase bearings that kept shifting as drones skimmed low, dipping behind berms and pipe racks. A key radar passed a target during a sector handoff and lost lock for a moment that mattered. That brief dropout forced a reacquisition cycle while new tracks stacked in the queue. This is where the failure mode showed. Engagement envelopes saturated. A Panzer fired out and hit its reload lag with more targets still live. Tor units pushed through search-to-track delays while their shot windows shrank. Jammers prioritized the wrong frequencies for the last mile, chasing decoys of their own making while the real guidance path ran outside their filter. The net didn't collapse. It slowed. In an 88-second fight, slow is a kill. The aim point wasn't a storage tank. It was the plant's brain. 4 impacts landed with intent. One cut the main electrical feed. Another took the backup. A third punched the logic controller that runs coolant pumps on an LPG sphere. The last blinded key pressure sensors. With power gone, brains offline, and eyes out, the safety stack couldn't coordinate a clean shutdown. Valves froze or lagged. Heat climbed where it should have fallen, and the system tripped into emergency states it couldn't manage. Output fell fast. Roughly 170,000 barrels per day went offline in under a minute, and fires kept crews busy for days. The backline wasn't safe. It was mapped, timed, and forced to make choices it couldn't make fast enough. We saw how the breach happened. Now we measure the cost beyond the flames. A fire you can see is one cost, The fuel you can't refine is the bill that lingers. In the last segment, we watched defenses stall in 88 seconds. Now the account comes due in aviation fuel, not just twisted metal. The refinery at Kostovo sits on a short list inside Russia, one of only 4 facilities that can produce TS-1 at the quality long-range aviation needs. That matters because strategic bombers and patrol aircraft don't drink generic kerosene. They need tight freeze points, clean burn, and reliable thermal stability. When you only have 4 taps that pour that grade, losing one is a system problem, not a local one. Thin chains snap under strain. Maintenance cycles already pull units offline in predictable windows. Prior strikes have pushed crews into emergency workarounds and delayed overhauls. Feedstock must travel by rail and pipeline across long distances, with blending windows that don't tolerate timing errors. Remove one TS-1 node, and the rest must shoulder throughput during the exact period they plan to slow down. That is how a single outage multiplies across schedules, inventories, and dispatch orders. You can watch the pressure show up in the export numbers. Russian refined product shipments slid to multi-year lows as output fell. Moscow then paused gasoline exports to hold down prices at home. That wasn't a headline flourish. It came after shortages spread across more than 20 regions, with the Far East and Crimea hit hardest. Industry trackers noted a September shortfall in gasoline output on the order of 1 million tons, roughly a fifth of normal domestic demand. When a state halts outbound sales to steady the home market, it signals a balance that is already tight. Inside the damaged plant, the clock runs long. Control systems burned, cable trays cooked, and safety valves that failed clean have to be certified again after replacement. In a modern refinery, that is not a wrench-and-go job. Logic controllers need staged commissioning. Instrument loops must be rebuilt, tested, and loop-checked under load. Early repair outlooks point to as much as 10 months before full throughput returns. That aligns with wider assessments warning that hit refineries may not normalize for many months given the scale of targeting and the complexity of process units. The money side is blunt. Kyiv's accounting for January through May cites about $1.3 billion in direct plant damage and $9.5 billion in indirect losses from halted production and broken logistics. They frame it as a $1 to $15 damage yield per strike. Strip out the rhetoric and the ratio still matters. Cheap drones trading for outsized industrial costs, with compounding effects in transport, insurance, and replacement fuel. What does that buy operationally? TS-1 scarcity means fewer training sorties, so aircrews stretch syllabi over longer calendars. Bomber tasking tightens, with mission planners forced to reserve fuel windows for priority flights and scrub lower payoff runs. Mixed fleets compete for the same pool, so long-range aviation wins on paper while tactical units accept reduced hours or staggered cycles. Readiness becomes a math problem of tanks, not tails. Policy follows the fuel. Imports rise where they can, often at a premium. Rail routings adjust to backfill regions starved of refined product, stressing rolling stock and terminals. Defending refineries deeper in the interior pulls air defense assets away from other nodes, and ensures raise rates on plants that sit within proven flight envelopes. Every pivot adds cost or risk, and none builds new TS-1 capacity quickly. So the real bill is not the blaze you saw. It's ongoing pressure on aviation fuel, emergency export moves, and a logistics drag that keeps tugging months after the flames die down. If a single mapped node forces this much rebalancing, the next question is how Russia stretches protection and supply when the following backline target enters the flight plan. 88 seconds didn't end with flames. They reset the calendar. Months of constrained TS-1 now ripple through flight plans and maintenance windows because industrial bottlenecks act like critical nodes in a war network. Watch the backline. Track TS-1 output, export pauses, and repair timelines, because the next strike will be measured in sorties denied and training hours cut, not headlines. Follow the data as deeper plants come under pressure and air defenses stretch to cover maps that keep expanding. If the backline isn't safe, the front line feels it. Subscribe for the next deep dive on how these mapped nodes set the tempo of the war.